The avant-garde James Webb Space Telescope has dramatically delivered the most precise depiction of Proxima Centauri b to date, offering extraordinary insight into a potentially habitable exoplanet. It invites us to embark on a cosmic odyssey to decipher the mysteries surrounding Proxima Centauri b and assess whether it might serve as our next terrestrial sanctuary. We traverse the vastness of the cosmos, where a mysterious celestial entity exists within the habitable zone of its star, Proxima Centauri. This planet isn't merely any commonplace rock. Its existence is remarkable. Proxima Centauri b lies approximately 4.2 light-years from Earth, making it the closest confirmed exoplanet to our world. This planet is enveloped in enigma and wonder. Might it be another Earth, with sprawling seas and flourishing life on its terrain? Still, the tale continues. Proxima Centauri b doesn't orbit alone in its stellar system. It shares the system with a sibling, Proxima Centauri c, which circles the red dwarf star. And who can say what additional secrets this stellar neighborhood harbors? Perhaps there's yet another partner awaiting discovery. The suspense heightens. Proxima Centauri emits an energy output roughly comparable to what Earth receives from our Sun. Could this genuinely suggest the presence of liquid water and possibly life? Venturing beyond our solar system, we discover an entirely fresh realm of exoplanets, worlds orbiting stars other than our own. With an estimated 200 billion stars in the cosmos, the possibility for exoplanets is limitless. A number of these exoplanets even drift aimlessly through interstellar space, unanchored to any star, like solitary nomads in the universe. Among them, Proxima Centauri b stands apart as an extraordinarily enchanting and compelling world. Its orbital period lasts a mere 11.2 Earth days, and its orbital radius is nearer to its star than Earth is to the Sun. Consequently, one hemisphere of the planet basks in constant daylight, while the opposite side lingers in eternal darkness. Let us now examine Proxima Centauri, the star around which Proxima Centauri b revolves. Proxima Centauri is a component of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri b. Together, these stars form the closest stellar assembly to our solar neighborhood. Alpha Centauri A and B constitute a binary duo called Alpha Centauri AB. These G and K-type stars appear as a single point of light in the Centaurus constellation and rank as the third brightest stars in our evening sky, with a maximum brilliance just under magnitude 2.7. Proxima Centauri, also known as Alpha Centauri c, is a red dwarf, an M-type star, located 4.2 light-years from its stellar companions, roughly 4 times the Earth-Sun separation. It holds the title of our nearest stellar neighbor. The term Proxima means nearest in Latin, and it was identified in 1915 by Scottish astronomer Robert Innes. Despite being our closest star, Proxima Centauri is invisible to the naked eye, with an apparent magnitude of 11.13, far dimmer than the human threshold of around magnitude 6.5. Yet don't be deceived. Proxima Centauri remains a stellar object meriting thorough investigation. Red dwarfs like Proxima Centauri rank among the most efficient energy producers. Although they emit less luminosity, internal convection within their cores sustains them for trillions of years. In fact, Proxima Centauri is expected to burn on the main sequence for approximately another 4 trillion years. Nonetheless, the habitability potential of a red dwarf star like Proxima Centauri is still debated. For starters, it's a flare star, experiencing regular and intense stellar outbursts. Given its low mass, the habitable zone would be much closer than the Sun's, estimated between 0.23 and 54 cents, but that doesn't guarantee hospitable conditions. Proxima Centauri b is relentlessly bombarded by intense ultraviolet radiation from its star, far more powerful than that which Earth receives from our Sun. In fact, the radiation is so fierce that even the lightest atomic particles, hydrogen, nitrogen, and oxygen, are torn away. And that's not all. Being at the right distance from its star doesn't mean it can sustain life. Proxima Centauri b might lack a stable atmosphere, vital for temperature regulation and sustaining liquid water on the surface. Without such an envelope, biological organisms would be vulnerable to powerful stellar weather, making life virtually impossible. So, although Proxima Centauri b may seem Earth-like at first glance, it could be far from hospitable. Researchers remain cautious, as numerous factors suggest it might not support life. The quest to reveal the truth about Proxima Centauri B continues. One instrument capturing astronomers' attention is the James Webb Space Telescope. After years of anticipation, the observatory launched in 2018 and will assist in determining whether life exists on Proxima Centauri B. Yet, in all scientific endeavors, complexities abound. Several calibrations were essential to ensure the James Webb Space Telescope produces accurate data. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima Centauri B can absorb stellar light, it can also emit it as infrared radiation. The James Webb Space Telescope was specifically engineered to detect infrared light. It can capture visual data of this light from the planet's surface and seek out patterns that could corroborate the presence of water or an atmosphere. But what if the planet's atmosphere isn't suited to life? The existence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima Centauri B could resemble Venus, with a dense atmosphere significantly thicker than Earth's and extreme temperatures that would make it impossible for life to exist. Deciphering the enigmas of Proxima Centauri B presents significant hurdles. While the James Webb Space Telescope promises breakthroughs, other variables must be addressed. As costs spiral upward, astronomers feel pressured to develop strategies to observe planets like Proxima Centauri B. The stakes are high, but the rewards could be even higher. The chance to probe the unknown, to expose the secrets of a distant planet with life-harboring potential, is a mission worth undertaking. If the exoplanet is indeed habitable, could we one day travel there? Since it is the closest exoplanet, it's irresistibly enticing, almost like exploring our cosmic backyard. What's more, it's nearly Earth-size, and its habitable zone position implies it might have conditions conducive to life. Proxima Centauri B's proximity also makes it an ideal candidate in the quest for life beyond Earth. Being so near, it's a prime target for interstellar mission concepts. Picture the thought of exploring this Earth-like world. Although we currently can't physically voyage there, future missions might place it on the agenda. As engineering progresses, it stands among the most exhilarating undertakings in space exploration. Yet the venture is far from trivial. For instance, at Voyager 2's current velocity, it would require roughly 75,000 years to reach the Proxima Centauri system. Nonetheless, one proposed solution involves solar sails, ultra-thin reflective membranes that could propel a spacecraft toward the Alpha Centauri system, including Proxima Centauri. This innovation exploits radiation pressure from sunlight to sustain its trajectory, eliminating reliance on conventional fuel. Moreover, this advanced propulsion approach could yield vital data about life on remote worlds like Proxima Centauri B. However, as with all bold designs, limitations remain. Merely having an atmosphere doesn't guarantee habitability. Proxima Centauri B might bear similarity to Venus, swathed in a thick, scorching atmosphere that renders its surface uninhabitable. Additionally, the James Webb Space Telescope can detect emissions even if they constitute only 5% of the brightness of the planet's dayside. Though it may seem marginal, given the relative faintness of its host star compared to our Sun, the finding is highly significant. If Proxima Centauri B harbors advanced civilizations, they might even deploy vast orbital mirrors to redirect starlight from the perpetual dayside to the dark hemisphere. How awe-inspiring is that? The universe teems with innumerable exoplanets awaiting discovery. These celestial bodies span an immense range of types and dimensions, from massive gas giants to rocky terrestrial spheres. One noteworthy exoplanet category is gas giants, akin to Jupiter and Saturn but often significantly larger. Some are termed superjupiters, surpassing even our solar system's largest planets. But there's more. There are also hot Jupiters, enormous gas planets orbiting extremely close to their stars, where temperatures could liquefy metals. Imagine witnessing such a world up close, amid torrential storms and blistering heat. In addition to gas giants, Neptunian exoplanets share characteristics with Uranus and Neptune. Among these subgroups are hot Neptunes and mini-Neptunes, smaller, closer kin to their gas giant cousins. These celestial bodies often remain enigmatic due to the difficulty of probing their atmospheres from afar. Let's not forget Earth-like exoplanets, worlds bearing strong resemblance to our own. They vary from slightly smaller than Earth to over twice its mass. Within this category are super-Earths, which possess greater mass than our planet but remain lighter than ice giants like Neptune. One of the most enthralling recent exoplanet discoveries is Proxima Centauri b. It orbits its namesake star and is classified as a super-Earth, with a mass approximated at 1.17 times that of Earth. Although it circles near its star, it could still lie just outside the classical habitable zone. Furthermore, Proxima Centauri b isn't alone. It has a counterpart, Proxima Centauri c, which orbits further from the star. This planet takes roughly 5 Earth years to complete one revolution and was confirmed in 2020 using archival Hubble Space Telescope observations. Even more riveting is the proposition that Proxima Centauri b might be unusually bright, potentially due to a ring system reflecting starlight. But the intrigue doesn't end there. In 2019, astronomers detected an odd variation in Proxima Centauri's radial velocity, possibly signaling another planet. If substantiated, this world would be designated Proxima Centauri d and is estimated to possess a size comparable to Mercury or Mars. Visualize a night sky rich not only with stars, but brimming with alien planets, each with its own features, climates, and orbital paths. The cosmos is a trove of marvels, and exoplanets rank among its most enthralling contents. With ongoing exoplanet discoveries arriving frequently, it's an exhilarating epoch for planetary scientists and astronomers. Although the precise number of exoplanets remains unknown, it's clear that they are as abundant as stars themselves. However, observing these distant worlds presents daunting challenges. They're often hidden by the overwhelming glare of their parent stars, complicating direct detection immensely. Yet, advancements in technology have recently enabled us to directly image select exoplanets. To achieve that, a planet must be sufficiently massive, distant from its star, and young and hot enough to emit detectable infrared radiation, all highly specific conditions. But even these rare glimpses are profoundly enlightening. The majority of exoplanets are discovered not by direct imaging but through their effects on their host stars. A planet's gravitational tug can cause a star to wobble, a phenomenon known as radial velocity, which astronomers can observe. NASA's Kepler Space Telescope revolutionized this field using the transit method, observing subtle dips in starlight as planets transit their stars. This approach has yielded invaluable data on exoplanet sizes, orbital distances, and surface temperatures. Here are a few captivating statistics. Over 22% of Sun-like stars are believed to host Earth-sized planets within their habitable zones. The TRAPPIST-1 system contains 7 rocky planets, several of which may harbor liquid water. Analogous to moons in our solar system, many exoplanets are expected to possess natural satellites, exomoons. With more than 4,000 confirmed exoplanets to date, their ubiquity throughout the galaxy is evident. Hot Jupiters, with their immense masses and tight orbits, remain the simplest to detect. Yet innumerable other planetary varieties await discovery. NASA's James Webb Space Telescope continues leading these investigations, revealing cosmic mysteries every day. This spectacular observatory persistently gathers detailed observations and breathtaking imagery, illuminating phenomena previously confined to theoretical speculation. Most notably, it has recently made a watershed discovery, the first unambiguous detection of carbon dioxide in an exoplanet's atmosphere. This exoplanet orbits a Sun-like star around 700 light-years away, and the finding provides crucial insight into its chemical composition and evolutionary history. This achievement represents a significant advancement in our quest to identify extraterrestrial life. NASA Administrator Bill Nelson emphasized that this discovery presents a novel vantage on the universe, energizing the global scientific community. Additionally, the James Webb Space Telescope has captured awe-inspiring infrared visuals of the universe. In one example, it observed the object dubbed ISOL-10 IRS-4, which reveals a cloud of cool, ethereal material behind it. Orange hues accentuate the glow of remote stars veiled by ice and dust. This investigation falls under the Ice Age Initiative, an endeavor exploring how ice forms in space, from interstellar dust grains to icy comets. Moreover, the telescope has, for the first time, imaged the complex architecture of a dusty disk enveloping a nearby red dwarf star in infrared wavelengths.